Welcome to Ms. Math Presents Geometry Review. Today's episode, Coordinate Geometry. For slope, the first thing I usually do is determine if it's positive or negative. Now, slope we read left to right, just like we read words. And the way I do it is I think about it like my bank account. So here, with the graph on our left side, it is, as we go left to right, it's going up. Well, if my bank account is going up, hey, that's a good thing. I want more money. So it's positive. Here on the right, as I go left to right, it's going down. If my bank account is going down, that's sad. That's negative. So that helps me remember how to tell positive and negative slope. If we find our slope using the graph, the first thing we find out is positive or negative. For this one here, left to right, it's going down, so I know it is negative. Then I'm going to find two perfect points. Perfect points are ones who go directly through the corner of a box. So if we look through, we have several here, but it has to go through the corner of a box. So I find a point, there's one here at 0, 5, and another here at 6, 1. So I'm going to put those points there on my two perfect points. Then I'm going to count along the grid lines, my rise and my run. So on my grid lines, I count 1, 2, 3, 4, one scoop per box. And then I count my run. 1, 2, 3, 4, 5, 6. So my run is 6. Then I can write that out as rise over run. It is negative 4 over 6. I can simplify using Desmos, and we get negative 2/3. So our slope is equal to negative 2/3 for this graph. Now, using the formula, I have my same points, 0, 5, and 6, 1. To use my formula, I take y minus y over x minus x. Remember how we say this? You put yourself over your x, y's over x's, and when you date your x, it's a slippery slope, so this can help us remember. So I take y minus y, 5 minus 1, over x minus x, 0, minus 6. And I can put that in Desmos. I get back negative 2/3. So you see we get the same answer using our formula. For parallel and perpendicular slope, parallel slope stays the same. Perpendicular slope, we change the sign and flip the fraction. So here, for our slope of negative 2/3, parallel slope stays the same, negative 2/3. Perpendicular slope, we're going to change the sign and flip the fraction. Negative becomes positive, 2/3 becomes 3/2. For our next example, 3/7, parallel slope stays the same. Perpendicular slope, I have to change the sign. So when I have positive, it's going to become a negative. Flip the fraction, 3/7 becomes 7/3. So I have negative 7/3. For example 3, we have 1/2, parallel stays the same. For perpendicular, I have to change the sign, positive becomes negative, and flip the fraction. Now, 1/2 becomes negative 2 over 1, but we don't write the over 1 because it doesn't change the value. So we just write negative 2. For example 4, our parallel slope stays the same, negative 4. Perpendicular slope, we change the sign, negative becomes positive. We flip the fraction. Now, we don't see a fraction here, but when we have to flip that, negative 4 is the same thing as negative 4 over 1. So we just put the 4 underneath the 1 for our fraction. And again, it becomes positive because we had negative for the original slope. For midpoint, we have two methods we can use. To find the midpoint of AB, we have A, 3, 3, and B, -5, -1. To use the formula, we add our x values together and divide by 2, and add our y values together and divide by 2. So I can write out my formula and replace my x's and y's with our x's and y's. So x sub 1 plus x sub 2 is replaced by 3 plus -5, and the y's are replaced with 3 and -1. I can plug this just like I see it into Desmos to simplify, and it gives me back -1, 1 for my midpoint. Next, I can try this on the graph as well, and if I forget the formula, then I'm going to automatically go towards graphing to find my answer. So, to graph, I plot my points, and then I count along my grid lines. So I count 1, 2, 3, 4, and then I count over 1, 2, 3, 4, 5, 6, 7, 8. So I know up 4 and over 8 is the whole way from point B to point A. Now, if I want the midpoint, I'm going to go halfway. So I'm going to take each number and go half of that. So instead of going up 4, I'm going to go up 2. 1, 2. And instead of going right 8, I'm going to go right half of 8, which is 4. 1, 2, 3, 4. And that lands me on my midpoint at -1, 1. So with both methods, I find the same answer. So I can use my choice of formula or graphing. Lastly, we're going to look at distance. For distance, our keywords to look for are distance, length, or how far. So we have 2 points, A, -5, 4, and B, 3, -2. And it says find AB. Now, when we have a segment name, AB, with no line above it, that means the length of AB. So step 1 is to plot the points. So I have -5, 4, and 3, -2. And then I'm going to draw a right triangle. So I connect those two, and then I follow the grid lines to draw a right triangle. From there, I can use my Pythagorean theorem, but I need to count the length of each leg first. So I count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8 are the lengths of each leg here. Then I can use my Pythagorean theorem, a squared plus b squared equals c squared, to solve for c. Opposite our box, our right angle, is c. That's going to be x, because I don't know that value. A and b can be either side. I usually make a the smallest, so I replace a with 6 and b with 8. 6 squared plus 8 squared equals x squared. I plug it in Desmos to solve, and I get back that x equals 10. So the length of AB is 10. Thanks for watching this episode of Miss Math Presents Geometry Review. Have a great day.